Assalamu alaikum. I welcome all of you to the lecture series on basic concepts of chemistry. As previously I gave some simple examples or molecules of which the hybridization was to be determined. So today I am trying to solve those questions, and these are the answers. First one was acetylene, this ethene molecule. And the questions asked were that what is the hybridization of this carbon, and of course after hybridization what will be the geometry of the molecule, and it doesn't have any lone pair or non-bonding electrons, so the third part of the question doesn't apply on this molecule. So let's see. It's one of the simplest molecule. As you see, this carbon, it is sp squared or sp2 hybridized, because the carbon forms, it's a simple example, because the carbon forms 4 bonds here. There are 3 single bonds and 1 double bond this carbon is forming. So just because of this double bond, we can just say by looking to the molecule that this carbon is sp2 hybridized. Okay, and it is a very simple molecule. There are no other moieties or groups present in this molecule in order to change the geometry or to deform the structure of the molecule. So we can say that this molecule is sp2 hybridized, and the bond angle here are 120 degrees. Okay, so this is the first molecule, but up that the other molecule, which was a little bit complicated than this one, not entirely, but it seemed a little bit complicated than the molecule. There are 2 hydrogens atom, and there was a positive charge. So in this molecule, as you see that this carbon, okay, so this carbon again is also sp2 hybridized. Okay, these all bonds are sp2 hybridized bonds. Here is one sigma bond which is also sp2 hybridized between carbon and carbon, and a pi bond is also there, as you know. Again, it seems like the same situation that we are repeating. Here nitrogen has positive charge, but this positive charge here it appears on the nitrogen because it has donated its lone pair to some proton. Okay, so nothing else. Again, this molecule is a flat molecule, and this carbon atom, this is sp2 hybridized, this is again sp2 hybridized. Okay, and almost the angle between those 2 hydrogens and those 2 hydrogen is 120 degrees. Okay, now I have also given the third example. So I should not erase it right now. Okay, the third example was this one, carbon with non-bonding electron on it, electrons or an electron pair on it. This carbon is called as carbonyl. So as you see that what will be the hybridization of this molecule, because we should not go for the tricks, we should see individual molecule. Okay, there are many tricks that you can do it, but my aim is to make you understand this basic chemistry. Okay, so suppose these are 3 hydrogens atom attached. Again, by looking at this molecule, we can think that this thing is should be sp2 hybridized, sp3 hybridized, it seems to be. But in fact this molecule is in fact sp3 hybridized, but how the orbitals looks like, you will see that these two carbons, okay, this molecule, this carbon is sp3 hybridized, and now when it is sp3 hybridized, it can form 4 covalent bonds. What happens, this carbon atom now keeps its 3 electrons in sp cubed hybridized orbital. So this carbon forms bonds with 3 hydrogens by using its sp3 hybridized orbital. And again there is one sp3 hybridized orbital left, in which the carbon atom puts its lone pair of electron into it. So all the sp3 hybridized orbitals are utilized. And this molecule is quite similar to the nitrogen molecule. As you see, nitrogen molecule, or amine, sorry, this is called as ammonia, NH3 molecule. These two molecules are quite similar. Okay. But the angles in real tetrahedral molecule, which was CH4 methane, okay, which we took as a sample or a standard or a reference, it has the methane molecule has 109.5 degree of angle. Okay. What about this molecule and what about this molecule? As we saw yesterday, or that in previous lecture, that it's about 7.0 or 107 degree about. Okay. Now let's see this molecule. Its angle is about 107.3, something like that. Okay, so these angles are bigger than this those angles. The angles between the hydrogen, this hydrogen, and that hydrogen is 107. Here, the angle between this CH and this CH hydrogen, or this one and this one, is 107.3. What I mean to say is, these angles are bigger and these angles are smaller. One thing is for sure, that the nitrogen and the carbon both are sp cubed or sp3 hybridized. Okay, one thing is clear, sp3 hybridized. Now coming to the geometry, again it keeps, nitrogen keeps its lone pair in what? sp3 hybridized orbital, and the same, the carbon should keep its electron into the sp3 hybridized. But why this angle is more than this? One thing is sure, that both the molecules, this molecule and this molecule, they have the sp3 hybridized carbon and sp3 hybridized nitrogen. Okay, so but the angles here are larger and the angles here are a little bit smaller. So why those angles are a little bit smaller and these are a little bit larger? So I'll try to explain it through some concept of electronegativity. As you know that the nitrogen atom is more electronegative, okay, than the carbon atom. Now both, so what will happen? An electronegative atom, what does it do? It loves electrons, okay, or it want to keeps its electron very much near to it. So the lone pair here will be, let me erase this, the lone pair here will be almost very near to the hydrogen, okay, nitrogen, because nitrogen is more electronegative and it will attract the lone pair towards itself. And this carbon atom, it has a little bit less electronegative than the nitrogen atom, and what it does, its lone pair is a little bit above, okay, extended outward. Now what they say, that just because the lone pair on the nitrogen is very much near, or almost sitting very near on the nitrogen, okay, so it can push, or it can exert more pressure, and it can compress, or you can say that it can shrink the bond angle more. So this is smaller, and this shrinks, it's a little bit lesser, so it is a big angle. Okay, but believe me, when you go and dig scientifically, there are other regions and other things which will come into play, and those are more important. Those are just reasons which are made for fresh chemistry students, that who should understand, or who should at least think that how does why these angles are smaller and those angles are larger. Okay, but in reality there are many other things, and when you study those things in a little bit detail, or in an advanced way, you will see that the hybridization of all those atoms are a little bit different from each other, a little bit different. And there are many other variations in those molecules, but for a basic course it is very much okay that you can say that this carbon atom is less electronegative, and its electron cloud is a little bit above, expanded above, and this is more electronegative than nitrogen, so its electron cloud is very much on the nitrogen, so it can exert force on those, and it shrinks the angles to 107 point, so exactly about 107, or you can say that the angle of these are smaller and the angle of those are larger. Okay, now as I have also given an example of Bh3 molecule, and majority of you, those who sent me the messages, they have corrected it, because when you go to the boron electron configuration, you quickly know that it is Sp2 hybridized boron. Okay, and I should not repeat the boron the electron configuration, because you know, and it will make this a little bit more lengthy. So this is Sp2, okay, Sp2 or Sp squared, and all these bonds are Sp2. Now again I have given another example, which was this one, C plus, and again 3 bonds. As you see this, when you see the structure of boron, what happens? Let's go to the when you go to the excited states of this, in the 2s orbital of boron there are 2 electrons, and here it has 1, okay, in the 2p, and 1 electron quickly excites. What hybridization says. Hybridization is okay, and now because 1p become vacant, it could be px, py, or pz. Okay, so it doesn't matter. So this p is vacant, and now these 3 overlap together and form Sp2 hybridized. This is excited state of boron, not a ground state. In ground state this electron would be here. So what happens? It produces 3 Sp2 orbitals, 3 in number. Okay, there are 3, and 1 vacant p orbital which is present on the boron atom. And suppose this is a boron atom, my fingers, it's half towards you and half right here, because the boron is a flat molecule. It's like this. This is the example. Okay, this is boron, these are all, this is boron atom, suppose. Okay, this middle one, let me extract the pencil out of it. This middle one is a boron atom. These are hydrogen, 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 and the p orbital, it is vacant, it doesn't have anything in it, so it is like this. Okay, the boron atom, the p orbital is perpendicular, and we have written the molecule like this. Okay, on the board My one is not that correct, but anyhow it is okay. And now the p orbital is like this. But what about this thing? If as you see it a little bit clear, if you look to the structure a little bit closely, it resembles like this boron. Okay, so how it would be formed, we don't know. But suppose it is formed from suppose we say that it is produced from CH4, which was tetrahedral. Okay, this molecule, and here was some group, suppose. Okay, and this group along with the electron went out and a positive charge is left behind here. Okay, so what would happen? There would be one thing, it will become a plus charge thing. Okay, now it will become a plus charge, positive charge will appear because both electrons, the thing which was X or anything, it took the electrons along with itself. But now this thing, but one thing should be there, one thing you should remember, that I have told you once that there the Sp3 hybridized orbitals, they have higher energies, suppose. Okay, and Sp2 hybridized orbitals have lower energies, just like this is CH. This CH bond is between Sp3 carbon hydrogen, and this CH bond is between, this one is between Sp2 hybridized carbon. So this is in lower energy state, this one is lower, this bond is lower energy bond. Those all energies in the coming lectures you'll understand that why I am repeating those energies. These are, believe me, those energies are responsible for the chemical reactions, and now just because of those you will be able to understand that why some of the molecules react rapidly, fastly, and the other are reluctant to do reactions or are unable to do the reactions. Okay, so this is low energy, this is energy up, this is lower energy. What thing I am just comparing? Those bonds, this thing and this thing. Okay, this CH bond and this CH bond is lower energy. Now those all CH bonds were first of all what they were. Suppose this is X, and X might be something, let's say it is a halogen or anything, but what happens, it took both the electron with it. Okay, and it went along with the electron as a negative species, so it will become a positive. But when this become positive, what will happen? Because first of all it was Sp3 hybridized. Now one thing the molecule can adopt, if it keeps all the three as Sp3 hybridized. Okay, so no electron, so when it keeps all the three hydrogen bonds as Sp3 hybridized CH, it is not that good, and other arrangement is far more better than this one. What is that? This molecule or this atom carbon will rehybridize itself. Why? How? It will now it will rehybridize itself from the Sp3 to Sp2. Okay, so when it becomes Sp2, what will happen? This molecule, the energy of the molecule will decrease. What does the decrease in energy of molecule mean? The molecule will become a little bit more stable. So in Sp3 form it is not stable, and in Sp2 form again it has a positive charge. The positive charge is a sign of instability. Okay, it's this thing is unstable, or the positive charge again it makes this unstable. But now this molecule convert to Sp2. So because here this orbitals it is empty again. Okay, because it is a positive charge, and suppose a thing went out of it and it is empty, but it is an S character is here. So the S character what is the S character? The S character represents stability, okay? And another thing is associated with S character, which I will tell you a little bit in the when I will be explaining the other examples. So the S character, what happens? The S character comes back to the carbon and it is distributed between those hydrogen atoms. Okay. So when this is distributed between the hydrogen atom, what does the S character do? As you know that in let me tell you one thing. In Sp3 hybridized orbital methane, suppose, okay, CH4, the bond angle was 109, okay, but in Sp2 hybridized, now the S character is increased, or you say there are now 2p orbitals and added together with one S, so that you can say that the p character is decreased or the S character is increased. So as the S character increases, the bond angles increases, okay. So in Sp3 the bond angle were 109, in Sp2 the bond angle became 120. So this molecule, what the Sp2 does? The Sp2 does one thing. It gives the stability to the CH bonds, okay, 1, 2, 3, because in CH3 it would be very unstable. So the molecule transfers itself to the Sp2 hybridized orbital and keeps its high energy 2p orbital vacant. Okay, how? Now, so these are the bonds which are formed. This is Sp2 hybridized, CH, and the bond is formed by Sp2 and H, Sp2H and Sp2 carbon and H. But as you know that one orbital will be left behind, because this was Sp3 and it immediately convert this orbital, because this has some S character and S is important for stability. So the molecule quickly get its S character back from it and keep this vacant orbital Sp. Okay. What is stability? Stability is S. The S gives the stability of the molecule, and S also widens the angles. So the molecule is very, what they say, cunning, you can say, or intelligent. So it takes the S character from this vacant orbital and keeps its P, and now it is almost like the boron. Okay, look at those things. So now it is a little bit stable than this thing. This is not stable. Again, it is carbocation, which we will explain in the reactive intermediate course, which is already started. So as you see that this is very much unstable, as this has a positive charge. I am forgetting positive charge. Okay, this is again a positive charge, but this is a little bit stable than that. Okay, and it has now, as the P is vacant, it is just like this boron. Bh3, okay, molecule. The P will come towards you. So what about the angles? The angles in those things are 120 all. And the CH bond is lower in energy. The molecule came to a lower energy and just kick out a p orbital. You can say that it was bitter in taste, or it just took the sweet S inside and throw the bitter p orbital. So the p orbital remain vacant and it is like this. Okay, this is another molecule. Let us move to the third molecule. Which one was it? Okay. When you study my quantum mechanics class, then you will be able that what actually is hybridization. Okay, but now we are just, because you don't, majority of you may not be familiarized with the waves, the wave function, the square root of wave functions, orbital distortion, symmetries, or those things. Okay, and energies. But I have explained that there. Okay, but now it's very in a simplistic form. You are understanding this. So there is another molecule. Look at this. It is nitrogen. Again, a different type of nitrogen. It has two eyes, pair of eyes. or this is hydrogen and this is hydrogen. When you look to this molecule, it seems it will remind you something. As you know that this has a negative charge, because when you calculate the formal charge, this molecule will become negative. Okay, so what it will remind you? It can remind you of oxygen, H2O. So this molecule is just like H2O, not okay. And what happened? It is again Sp3. This is Sp3, and now what happens? These molecules become Sp3 and Sp3. Okay, these bond Sp3. So it keeps 2 lone pair in Sp3 orbitals and make bonds with the 2 hydrogen with Sp3 orbitals. Okay, Sp3. This is Sp3 bond between N and because nitrogen is using Sp3. Here again the nitrogen is using Sp3, and the 2 lone pairs are again present in the Sp3. Because lone pair, because you also need to stabilize the lone pair. You cannot just throw them to the peak orbital. Okay, so the molecule looks to all its parts. It will stabilize the bond, okay, and it will also stabilize the lone pair. So all the things are in Sp3 orbitals. In Sp3 orbital, the 2 Sp3 orbitals form a bond with hydrogen, and in 2 Sp3 orbitals it keeps its lone pairs. Okay, and lone pairs. So this is Sp3, and it is very much near in geometry to water. What is a bent molecule? And this thing is again also, you can say, a sort of bent molecule. So let's go to the other molecule. In NH4 molecule, I have given you an H, and an H, and plus charge was there. As you look to this molecule, again no lone pair on the central atom remains. Okay, so it reminds you of methane. Okay, carbon, hydrogen, 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 and hydrogen. Again this thing is Sp3 hybridized. This is this nitrogen is using Sp3 hybridized orbital, and this carbon is again using Sp3 hybridized orbital. So both the structures are tetrahedral. The nitrogen, it will look like this, a little bit, not 100% like the original tetrahedra, but it is tetrahedral. Okay, because don't be confused with the nitrogen and carbon, because here the things are almost similar. So it is a tetrahedral, and this thing, as you know, is tetrahedral sp cubed hybridized orbital. Okay, so I hope that I have explained the thing which explained what I have given. Those were the answers of the questions which I posed to you.